Hello, Nitin Babu.
Sir.
Okay. Okay.
Okay.
Okay. Next, we want to discuss Prim's algorithm. Okay. So, think MST. Okay. Minimum span. Okay. So, we already discussed Pascal's algorithm. Now we want to discuss Prim's algorithm. Okay. So, you can note here this steps 1 to 5 is basically initialization step. Okay. This is initialization. Okay. So there is a graph G and a weight corresponding to each vertex R. Okay. R means root of the graph. Okay. From that root we will try to create a minimum spanning tree. Anyway, next we want to initialize all vertices other than the root. Okay, you can think is this is basically V minus R. Okay, R is the root vertex. Okay, R is the root vertex, and we want to initialize all other vertices than all other vertices. Okay, except the root. So we want to initialize the key value of each vertex as infinity and u dot pi. What is u dot pi? Pi is used to store the predecessor. Okay, so it is initialized to nil. Okay. It is initialized to nil. Okay. Then the root vertex R is its initial key value is 0. Okay. Cannot. So the root vertex R is initialized with its key value 0. Okay. So cannot do that. All other vertices are initialized in this way. Okay, for each u belongs to u dot v, u dot e is equal to infinity, and u dot pi is equal to nil. Then there is a priority queue. There is a two data structure involved in this algorithm. Okay, so this is we can think it as a priority queue. Okay, we can think it as a priority queue. Okay, so what is a priority queue? A queue in which insertion and deletion is performed by using some priority. Okay, so we can think about like this. There is a priority queue attached. There is a priority queue. Okay, this is a priority queue, and it consists of vertices. Okay. Okay. It consists of different vertices and associated values. Okay, so you can think in this way. For example, suppose this is the root vertex, then R will be here. Then this is actually the key value. Predecessor pi value of R. You can imagine a queue this way. Okay, so basically it is a priority queue organized in this way. Okay, vertex or vertices is there, corresponding parameters, key value is here and predecessor value is here. In this way the priority queue is organized. Okay, so there is a priority queue okay, which contains G dot V. Okay. G dot V means it contains all the vertices initially. Okay, so it contains all the vertices initially. Okay, next, okay, please give the attendance in the chat box. Okay, please give attendance in the chat box. Okay. So this is about the first part. Okay, this is about the first part up to this 1 to 5. Okay, then the next part is, so 1 to 5 is finished. So what is queue means? Queue is a priority queue which consists of various vertices. You can imagine the structure of queue in this way. Okay, this is a queue and then it contains vertices for storing the vertices data. For example, this is root node and corresponding key value. Okay. In addition, corresponding pi value. Okay, pi value. In this way, different vertices data, vertex data is organized. Initially, it is organized in this way. Okay. So this is the queue. Next, while queue not equal to empty, this is a for loop. Okay, this is a for loop. So while queue not equal to empty, if the queue is not empty, then we want to do this task. Okay, we want to do this task. At first, we want to extract the minimum element. Okay, you can note here, u equal to extract min of q means there is a queue organized like this. It is a priority queue. Basically, the priority queue I can define in this way, PQ. Okay, so in this priority queue, the insertion or deletion is based on this key value. Okay, that is priority queue. Based on the priority of the elements, insertion and deletion possible. Okay, so here first we want to extract the minimum element from the queue. Okay, that is the first step. Okay, so it is u. Okay, now it is stored in a variable u. Okay, then for each g dot adjacent of u. Okay, in this step I taken the vertex with the minimum key value. Then for each v belongs to the adjacent of that vertex. a note here. For each v belongs to g dot adjacent of u, we want to perform something. Okay, what we want to do? We want to do this. Okay, that is, we want to check a condition. If v belongs to q and w of uv less than v dot key. Okay, we want to check a condition. If the condition is true, then we want to do these two steps. 10 and 11 we want to execute. Okay, so what is WUV? What is WUV? Just the weight between. What is WUV? Weight between U and V. Okay, weight between the U and V. U is the vertex with the minimum weight. Okay, U is the vertex with the minimum key value. Okay, U is the vertex with the minimum key value. V is the adjacent vertex. Okay, so this is W. Okay, this is W of UV. Okay, so we want to check this condition. If V belongs to Q and W of UV less than V dot key, so it having some key value. Okay, it is having some key value. So we want to check this. If V belongs to Q and W of UV, U to V less than V dot key. V dot key means the key value of this node, V dot key. Okay. Then we want to do these steps. Okay. Then again we want to this step it will repeats, then this while loop also repeat. Okay, so this is the basic working of the Prince algorithm. Now we can focus on how we are going to implement, how this algorithm will work. Okay, how this algorithm will work, that we want to analyze next. Okay, okay, so here is a graph. Okay, this is very important. In the university exams, they will give a graph and will tell you to find the minimum spanning tree using Prim's algorithm. Show each step. Show each step in the method. Okay, so we want to the first. What is the first step? You can note here. What is our first step? We want to do this initialization. Okay, this is basically the initialization step. Okay. We want to do the initialization. Okay, so what will be the condition of the graph after initialization? This is basically the initialization. Okay, so the thing is, we want to set the root r dot key is equal to 0. Okay, so what is the key value? We want to set the key value of each node. This is 0. What about others? It is infinity. Okay, r dot key means the key value of each node should be initialized to infinity. Should be initialized to infinity. This is the initialization step. Okay, this is the initialization step. Here we will initialize the key value of each vertex to infinity, and the root is 0. Okay, the root is 0. Root's key value is 0. Okay. Okay. So that's about the initialization step. Also, there will be a priority queue. Okay. So how the priority queue will be organized? How the priority queue will be organized? Which as I told earlier, this is a priority queue, and and it consists of the root node R and its key value. What is the key value of R? It is 0 now. Okay, so the key value of R is 0, and other vertex and corresponding key value. These key values are infinity. Okay, the priority queue or queue will be initialized like this. Okay, the queue will be initialized like this. The root node is there and its key value is 0. All other nodes are there. For example, B is there. It is initialized with infinity. C is there and so on. I'm not writing all. Just understand the concept. This is the situation now. Okay, after initialization, this is the situation. Okay, so next what we want to do. Okay, now as I told, the core of the algorithm is the core of this algorithm. Okay. The core of the algorithm, this is the concept. Okay, I want to execute these steps. Okay, I want to execute these steps. So first I want to check where the queue is empty or not. Okay, is it empty now? No, because the queue contains elements. Okay, it's not empty. Then what I want to do the next step, I want to extract the minimum element from the priority queue. Okay, so if the queue is not empty, my next step is extract the minimum element from the queue. So now we can note here to 0. The root is initialized to 0. Root's key value is 0, which will be the minimum vertex, which will be a vertex with the minimum key value. It will be root. Okay, it will be root. That is why it is initializing in this way. Okay, root is initializing to 0. So we will extract the root. Okay, that is the next step. Okay, I am going to here, u is equal to extract min of q. I extracted the root. That is, I removed the root. Okay, I removed the root. So priority queue and the root is extracted. So it is removed from the priority queue. Okay, so the root is extracted. Then the next step is find the adjacent. Okay, take the adjacent vertex of that root. Okay, so I want to take I want to do it for all adjacent vertices. Okay, I want to do these steps for all adjacent vertex. Okay, I am taking one adjacent vertex. Which is the adjacent vertex? B is an adjacent vertex. Okay, B is an adjacent vertex and H is also an adjacent vertex. Okay, so there are two adjacent vertices. I can process any of the adjacent vertex. Okay, so next what I will do. Okay, so suppose here I taken B. Okay, suppose here I taken this B. Okay, then what I will do? Then I will check if V belongs to Q. Yes, V actually now it is V. This is V now. Okay, this is V now, and this is U. Okay, now V belongs to Q. Yes, V belongs in this Q. Okay, so V belongs in this Q. Okay, and its key value is initially infinity. Okay, its key value is initially infinity. Okay, initially it is infinity. Okay, initially is infinity. So I am processing V now. Okay, so if V belongs to Q and WUV less than V dot key, this is another condition. Weight between U and V less than V dot key. Okay, is it true? Because that is what we will do. Weight between A and B. What is the weight between A and B? It is 4. Okay. Weight between A and B is 4. Okay. 4 less than infinity? Yes, true. Because V dot key is infinity now. Okay. So the way this value, this distance 4 is less than the key value of B. Okay, that is 4 less than infinity. The condition is true. Then what we will do? We will set V dot pi is equal to U and V dot key is equal to WUV. There are two steps. Since this condition is true, I want to do these two steps. V dot pi is equal to U and V dot key is equal to WUV. Okay. That is, I want to set the predecessor of V to U. Okay. That is, I didn't draw it here. Already I told there is another one more information is there, that is the predecessor information. It is set to what? A. Okay, it is set to A. Then this key value is updated. Okay, this key value is updated. What is the new key value now? V dot key is equal to the distance. So this value is now updated to 4. Okay, 1 minute. This infinity value is replaced with 4. Okay, this is 4 now. Okay, so after that, what I will do? Okay, I processed one of its naive only. Okay, I processed B. Now H is remaining. I want to process H also. Okay, this is done. After that, because I want to take for each V belongs to G dot adjacent of U. That is, I want to process the adjacent vertex of each. I want to process this also. Okay, these are two adjacent. I processed this also. I update U. Then I want to process H. Okay, then what will happen? So you can note here what will happen. Now I am processing this one. Okay, now I am processing this one. Okay, what will happen? First, I will check the key value. Key value. First, okay, 1 minute. This is the distance 8. Okay, 8 is less than the key value of H. What is the key value of H? Initially infinity. 8 is less than infinity. So what I will do? I will, here H is there, and I will update this to 8. Okay, H dot key is equal to 8. Okay, H dot key is equal to 8. Similarly, its predecessor is set to A. Okay, predecessor is set to A. Okay, so now this is the Q. So I processed both the neighbors of A. Okay, here. So then what I will do? then what will be the next step? You can note here, this loop is ended. I will again check this queue. Okay, this is the queue status now. Okay, this is our queue now. Okay, this is our queue now, and what we will do? Anyone? Anaga?
Yes, sir.
Okay, Anaga. What we will do next?
Condition check ചെയ്യാം. V queueൽ ഉണ്ടോ നോക്കിയിട്ട് weight less than V dot key ആണ്.
We already processed 2 elements. Okay, we already processed 2 adjacent neighbors. Then what will be the next step? So we completed this step. Okay, for the root element we completed this step. Then what we will do? We will exit from the loop. Then after again we will check the queue condition. What is the status of queue now? Queue empty ആണ് എപ്പോഴും. Check whether queue is empty or not. Now queue is not empty because still elements are there. Okay, VH, all other elements are there. Only the root is removed now. Okay, so the queue is not empty. Then what I will do? I will extract the minimum again. Which is the minimum now? H or V? Which is the minimum now? Okay, this is 4 now. Okay, so next again I will check the status of queue. Queue is not empty, so I will process the minimum element. So now which is the minimum element? V dot key is 4. This is 8. All others are infinity. Okay, all other vertex are infinity. So what I will do? I will extract which element? I will process B. Okay, sorry, this is B. Okay, it's not V, it is B. Okay, I will process B. Okay, I will process this node. This node I will process. That is the step I want to execute. Okay, so then the next I should select B. Okay, then next element should be B because B the key value 3. Now the key value of B is 4. It is 8. All others are infinity. This is already processed. So in the next step, in this step, what I will do? I will I processed this part and reached B. Okay, so next I will repeat the steps again from B. Now it is B, and from B what I will do? From B what I will do? From B what I will do? So its key value is 4. This is 8. This is 0. And these all others are infinity. Then what I will do? That is, we want to repeat the steps. Okay, so now this is basically the root. Okay, now this is root. ഒന്ന് പറഞ്ഞ ഒരാൾ പറഞ്ഞു. റൈസ ഖാലിദ് പ്രസന്റ് ആണോ? റൈസ് റൈസ ഒന്ന് മൈക്ക് ഓൺ ആക്കി പറയാൻ പറ്റുമോ? Now we are processing B. What should be the next step? Akhil C ഇപ്പോൾ present ആണോ? Akhil present ആണോ?
സർ.
അഖിൽ ഒന്ന് പറഞ്ഞ ഇത് എങ്ങനെയാണ് ചെയ്യുക നെക്സ്റ്റ്? നമ്മളിപ്പോഴും ബിയിലാണ് ഉള്ളത്. ഓക്കെ, സോ നെക്സ്റ്റ് സ്റ്റെപ്പ് എന്തായിരിക്കും? വിച്ച് ആർ ദ നൈബേഴ്സ് ഓഫ് ബി?
സി ആൻഡ്
എച്ച്. ഓക്കെ, സോ we want to process these two. Okay, we want to process this one and this one. Okay, so what is the, suppose I am processing this one C. Okay, then what we will do? Okay, what we will check? V belongs to that is, that elements belongs to Q. Okay, then WUV less than V dot key. Okay, we will check the condition. Okay, so WUV is 8. 8 less than infinity. Okay, so what we will do? This is 8. This distance, okay, this distance less than C dot key. C dot key is infinity now. 8 less than infinity. So what I will do? I will update the weight of C. Okay, update the key value of C. Now what is the C's key value? C dot key is equal to updated to 8. Surely it is added in the, it will be added in the queue. Okay, priority queue, it will be added. So it will be like this in the priority queue. I will add, I will take C. Okay, so C's key value is updated to 8. C's key value is updated to 8. Then what I will do? I will take the next, this one. Okay, this is H. Already H is in the queue. Okay, its value is 8. Now what is the value? You can check. Now we are processing H. Okay, Akhil, ഒന്ന് പറഞ്ഞേ. Now we are processing H. Okay, so what we will do? What is the distance? It is 11. 11 less than 8. Akhil, അതായത് നമുക്ക് എച്ചിനെയാണ് അടുത്തായിട്ട് പ്രോസസ് ചെയ്യേണ്ടത്. അപ്പൊ നമ്മൾ എന്ത് ചെയ്യും? ഈ വെയിറ്റ്, ഈ ലെങ്ത് ഉണ്ടല്ലോ, പാത്ത് ലെങ്ത്, ബി ടു എച്ച് എടുക്കും. എന്നിട്ട് എന്ത് ചെയ്യും? ദാറ്റ് ലെങ്ത് ലെസ് ദാൻ വി ഡോട്ട് കീ ആണെന്ന് നോക്കും. അതായത് ഈ ലെങ്ത് 11 ലെസ് ദാൻ 8 ആണോ എന്ന് നോക്കും. ഓക്കെ, അതായത് ഈ പാത്ത് ലെങ്ത് ലെസ് ദാൻ എച്ച് ഡോട്ട് കീ ആണോ എന്ന് നോക്കും. വാട്ട് ഈസ് എച്ച് ഡോട്ട് കീ നൗ? What is h dot key now? Which is 8. H dot key is basically 8. So h dot key is 8. Okay, so it is 11 greater than 8. So we will not update h. Then again we will extract the minimum. So which is the so I processed these two. Okay, I processed this one. Okay, Then I updated here. Then the next step, what I will do, after processing the neighbors, again I will check the queue. Queue is not empty. So what I will do, I will remove the key with the minimum value. Okay. There are two cases. Either I can choose C8 or H8. C or H I can select. But here I selected C. Okay, this I selected. So I move to this path. A, B, C. Now the next situation is C is the root. There I want to do the same procedure. There I want to do the same procedure. Now C is, imagine C is the root now. Then Q is not empty. Then I want to process its neighbor. This is one neighbor. This is one neighbor. And I will update the queue based on it. Then I will again find the minimum among them. Then I will move to there. Okay. In this way, it will get proceeded. Okay. So I will show the path. This will move to here. Then after doing this, this will be processed. This path will be processed. After that, this will be processed. In this way, it will move. Okay. This will be processed, and then H will be processed. Okay. In this way, it will move. Finally, you will get a minimum spanning tree like this. Finally, you will get a minimum spanning tree like this. Okay. Not like this, this also, then this also. In this way, you will get the minimum spanning tree. Okay, anyway, try to do this algorithm using the same example before the next class. Okay. Okay, thank you. Please give your attendance. Okay. Please give the attendance in the chat box. Okay. Starting from Akash. Akash Raji. Akash, Abhinav, order chat box litto.
So Vishnu ആണ് ചാറ്റ് ബോക്സിൽ ഇടാൻ പറ്റുന്നില്ല.
Okay.